Geometry class, this is Mr. Ryan coming to you from Bledsoe County for the first day of our home learning, which will be Monday, March the 30th. So what I'm going to need you to do is just stop right now, pause, but go and get your book and your calculator and get your paper from your notebook. And I really need you to follow through with me now. I'm going to simulate a class as close as I can, but I'm going to really need you to follow through and not just watch, but to do the work with me. So please do this. I'm asking you on your honor to follow with me on the work. It won't be that long. So now we're starting our first day in 11.1, similar figures, and that's on page 518 in the text. So we're going through the examples. So first, the book wants to show us a use for proportions, and the example 1 says, find the scale factor of a 7.08 inch long model Ferrari if the actual car is 14 foot 9 inches long. Now, in order to convert from 14 foot 9 inches, we have to, of course, multiply 14 by 12 to get the number of inches in 14 feet plus 9, which on the calculator, which you need now for every class, is 177 inches. So now we can go about getting the proportion. The proportion of the model car to the actual car length is 7.08 divided by 177, which comes up as 0.04, but I want you to be able to do math enter to see 1 over 25, which is a lot more useful in the way that scale models are actually done. So make sure you do the math enter on your calculator. Now we're going to start with proportions, and for proportions, which are two fractions set equal to each other, we most often use cross multiply. Now as you see the dotted dashed lines from A to D and B to C, that means we're multiplying across the equals on the diagonal. So when we see an A over B equals C over D, we multiply across the equals on the diagonal. A times D equals B times C. Now in example 2, the first one, we see a special type proportion, which when we look at x over 5 equals 9 over 15, we see that we could easily divide 15 by 3 and get 5. So since proportions are equal on the top and bottom, that means I could also divide 9 by 3 and get my proportion as 3 without cross multiplying. Now whenever you can see a divide like that, that's fine to do, and it's a shortcut. So the long way, of course, though, would be 15x equals 9 times 5, or 45, divided by 15, and of course it's x equals 3. Now on this next proportion, we really don't have any way else but to cross multiply. So see, you always multiply the one with the letter, the diagonal, so that would be 3.5y equals 2 times 14, or 28, and then we would divide on the calculator now. 28 divided by 3.5 is equal to 8. So my y equals 8. Now this is getting back to algebra. 2z over 4 is equal to z plus 1 over 3. So let's multiply 2z times 3 on the cross equals 4 parentheses z plus 1, giving us 6z equals, multiplying through 4z plus 4, subtracting 4z from both sides gives us 2z equal 4 and z equals 2. So now in this section we're doing similar figures, not just triangles, because we're going to see a trapezoid too. So this is why they're saying similar polygons, which remember can be any number of sided figures. So similar polygons are polygons in which the corresponding angles are congruent, actually equal, and the corresponding sides are all proportional. Now let's see what that means. On example 3, we have two triangles, PQR, which has sides 24, 33, and 27, and then the corresponding sides would be YXZ, which have 44, 36, and 32 sides. So now we can say by our definition, which is really a theorem there, that angle Q, the one which has the one arc in it, is congruent to angle Y, because they both have the single arc. And then also that angle R with the double arc in the first triangle is equal to, congruent to angle X in the second triangle with the double arc, and that's how we recognize them. So now we can say the third angle in each one, the third corresponding angle, angle P that's unmarked, is congruent to angle Z, which is unmarked, by a theorem that we had quite a while ago called two corresponding angles that are congruent in a triangle imply three triangles, the third one to be congruent, which is shortened as AA corresponds to AAA. Now let's see that the sides are indeed proportional. So PR, the bottom for the first triangle, would correspond to ZX on the second triangle. Notice how we can tell, because it's going from the unmarked angle to the double marked angle. So that would be 27 over 36, and if we divide top and bottom by 9, we get 3 over 4. Now let's take the next pair. PR over ZY, okay, would be 24, let me see, I'm having trouble seeing this, excuse me. PQ over ZY, excuse me, is 24 over 32, and dividing both sides by 8, we get 3 over 4 again, the same proportion. Now the third pair of sides, QR over YX, is 33 over 44, and dividing both by 11, we get 3/4. Okay, so now we can say that triangle PQR is similar, and that's the symbol for similar, to triangle ZYX, keeping their naming in the triangle, the letters, in the same that correspond with the angles. And with a proportion of 3/4 if I'm going from the small to the big triangle, or from the big to the small, 3/4 is, or K equals 4/3 if I'm going from PQR to ZYX, okay? We did it from PQR to ZYX. Okay, now example 4 is asking, can Katie scan an enlarged 4x6 photo and produce a similar 8x10 photo? Are those two photos similar? Well, let's look first at the width subfinal to the width suboriginal. So it's 8 inches to 4 inches for the width, which is a doubling factor. But if we look at the lengths, the 10 by 6, the 10 over 6, the length final to the length original, that reduces to 5/3, or 1.67 or 167%, which is not 2. So I can't make it 4x6 into an 8x10 and keep it similar. But what I can do is I can turn a 4x6 into a 6 2/3 by 10, and here's how. 4 inches times 5/3 equals 20/3, and 3 into 20 is 6 with a remainder of 2, so 6 2/3. So that's what the best I can do with a 4x6 to make it with a 10 length is to make it 6 2/3 by 10. Okay? Now, since we said we're going to be working with polygons, now we're going to be working with trapezoids. So example 5 says find each measure in the similar trapezoids J, K, L, M, and T, U, V, W. So you see J, K, L, M, J is 110 degrees, L, M is 20, L, K is, KL is 15, and V, U, V is 10, and WT or TW is 12. That's what we're given, okay? Now, first of all, we know that angle T is congruent to angle J because they're similar trapezoids. We're told that. So corresponding angles are naturally equal, okay? Then angle W, which they asked for, is 180 minus angle T because the top and bottom lines are parallel and the interior angles for parallel lines are supplementary, if you remember from back when we did that. So if angle T is 110, then angle W is 180 minus 10, or 70. And of course, angle M would be 72 because it's corresponding. Now let's look at some of the sides. If I take JM, see JM over 12, the big to the small, I could say it's corresponding to 15 over 10. That would be the similar side, big to small, big to small. So we're going to use our proportion, and multiply the 10jm first because it has the variable we want, equals 15 times 12, and on the calculator that gives me 10jm equals 180, and of course jm equals 18, okay? So now VW over 20 will be the top, from the small to the top on the big. So VW over 20 we'll say is 10 to 15, the small side to the big side. And we'll do our proportion and multiply through, cross multiply. 15 VW is 20 times 10 or 200. So 15 VW over equals 200 divided by 15, and 200 over 15 on the calculator, math enter, becomes 40 over 3, and 3 divides into 40 33 times with a remainder of 1, so 33 1/3, okay? All right, now here we start with the homework. Now, especially here, I need you to do this with me and not just watch, because I'm doing the homework like we do in class, but you've got to do it with me. So here's problem. We're going to be doing 2 to 26 evens all the time, just to make it consistent. So here we have problem 2. In a class of 30 students, 18 participate in the school band, and so now we want to get certain fractions. Band measures to students would be 18 band students to 30 total. Dividing both by 6, we would simplify to 3/5. If they ask us for non-band members to students, that would be 30 minus the 18, leaving us 12 that aren't in the band, and 12 over 30 dividing by 6 over 6 is 2 over 5, simplified. Now, band members to non-band members would be 18 band members over 12 that aren't, divide by 6 over 6, simplifies to 3 over 2. And all these fractions have to be simplified. Okay, now problem 4 is one where we can do 6 over x equals 54 over 63. You can recognize right off that 54 divided by 9 is 6. So therefore 63 divided by 9 must be 7, and that gives us our answer, x equals 7. Okay, now if we have the proportion 3 over 8 equals b over 2, then we'll cross multiply 8b over 6, and b equals 6 over 8, simplified to 3 over 4. Okay, now for problem 8, more algebra, z plus 7 over 15 equals z minus 2 over 10, and cross multiplying 15 times z minus 2 in parentheses equals 10 times z plus 7 in parentheses. And multiplying through, we have 15z minus 30 equals 10z plus 70. Now, in order to solve this, I'm going to subtract 10z from both sides, making it 15z on the left, 5z on the left. 15 minus 10 is 5z. And I'm going to add 30 to both sides, making it 70 plus 30 is 100 on the right. So just taking the steps, as you know how to do, is 5z equals 100, dividing by 5 is z equals 20. Okay, on 10, it says write a similarity statement and write an extended proportion relating the links, all 4 of them for these 2 trapezoids. So first we can say that JKLM is congruent to QRSP because they're telling us this, because they are similar. So the similarity statements is JK, which is the short side, over QR, which is the short side, equals KL, the side up from that, over RS, the side down from that on the other one, over L equals LM, the long bottom, over PS, the long bottom, or SP, and then MJ, the one coming back on the first, is equal to PQ, the one coming back to the top on the second. So all those 4 sides have the same ratio, okay, because they're defined to be similar. Now, looking in the textbook, it says find the similarity ratio of the red polygon to the similar black polygon. And we can see that would be 4 over 1 equals 16 over 4 equals 8 over 2 equals 12 over 3 is 4. So the sides are indeed proportional, all 4 of them, and K is 4. Now continuing on in problem 14, looking at the pictures in the book, which is why we need our book, find the value of each variable. So we can start with 9 over n equals 18 over 24. And again, we can use that shortcut. 18 divided by 2 is 9, so 24 divided by 2 must be n equals 12. Now this one we can't do that on though. 12 over m equals 18 over 24, multiplying across 18m equals 12 times 24. Need the calculator again. 18m is 288, dividing by 18, m equals 16 in my proportion. Okay, number 16, my two unknowns in the similar figures give me r over 25 equals 18 over 30. See how it's proportional side to corresponding side to corresponding side equals corresponding side to corresponding side. So we cross multiply. 30r equals 18 times 25 with the calculator. 30r equals 450. Divide by 30 on the calculator equals 15, and r equals 15. Okay, and now the next unknown that we need to solve for is s. So 12 over s equals 18 over 30. We can use the same pair on the two triangles. So 18s equals 12 times 30, and 18s is 360 divided by 18 gives us s equals 20. Okay? Now on 18, we have a mixture of 70% bluegrass and 30% ryegrass. So the fraction, the ratio of bluegrass to ryegrass is 70% to 30%, or 7 to 3. And we're told that we have 40 pounds of bluegrass, and we're asked to keep in proportion how many pounds of ryegrass should we have. So we'll cross multiply with the x first. 7x equals 3 times 40. 7x equals 120. And if I divide 7 into 120, I see that I get 17 with the remainder of 1, and that turns into 17.1 approximately. Okay? Now number 20 is given that this is a real simple one. X equals 5 equals y over 7. If we turn both sides upside down, we can see that 5 over x equals 7 over y. And if we cross multiply them, we see that we still have 7x equals 5y. So the cross multiplying works whether it's right side up or upside down. Now in 22, we're given that we have two similar triangles. LPQ is similar to triangle RST. So of course the first letter L is congruent to the first letter R in the second one. The second letter P is congruent to the angle P is congruent to angle S, the second letter. And angle Q, the third letter, is congruent to angle T, the third letter. And of course, my proportion is LP over RS is equal to PQ over ST, the second and third, equals QL, the first and the third, over TR, the first and the third. And that's my statement of two triangles being similar, that the corresponding angles are congruent and the sides are all proportional. Now on this figure, on this triangle for 24, looking at the corresponding sides, we have 6.9 over 9.2, which we need to use a calculator on to see that that comes out to 3 over 4. And the other pair of sides that are corresponding is 6 over 8, which simplify to 3 over 4. So the sides are all proportional. And we can say the triangle ABC is similar to triangle ADE, where the K equals 3 over 4 if we're going from the big to the small triangle, or K equals 4 over 3 if we're going from the small to the big triangle. And then 26 is really easy. Triangle STU is congruent. It's actually congruent, but it's still similar also to triangle SVU by SSS similarity with a K equals 1. And this concludes our first day of home learning for Monday, March 30th. God bless you and stay safe out there, and I'll be coming to you like this each day. God bless.